Today we're going to teach you about z-scores. A z-score is a standardized value that shows how many standard deviations the original observation falls away from the mean and in which direction. A standard deviation measures spread by looking at how far the observations are from their mean, and a mean is the average of all values in the data set and is the center of a normal curve. Important things to know is that a z-score has no units. If it's positive, it's above the mean. If it's negative, it's below the mean. It shows the number of standard deviations away from the mean, and we can only find z-scores for symmetric unimodal data. If x is an observation from a distribution that has a mean mu and standard deviation sigma, the standardized value of x is found by the equation z equals the original observation x minus the mean mu divided by the standard deviation sigma. Using the z-score, you can locate the area under the standard normal curve to the left of z with table A. This is table A. Our first example says if the original value is 28 and the mean is 26 and the standard deviation is 2, what is the z-score? By using our equation, we can plug in the original value 28 minus the mean 26 all over the standard deviation of 2 to get the answer of 1. This means that the value is 1 standard deviation above the mean. Example 2 asks, with a mean of 65 and a standard deviation of 4.1, what is the z-score of an original value of 57? By plugging in the original value 57 minus the mean 65 and divided by the standard deviation of 4.1, we get the answer negative 1.95. This means that the value is 1.95 standard deviations below the mean. If we have the z-score of 1, then that means that it is 1 standard deviation above the mean. If we have a z-score of negative 3, then that means it's 3 standard deviations below the mean. And if we have a z-score of 0, that means that the value is at the mean. In this word problem, a girl got an 84 on a test with a mean of 80 and a standard deviation of 1.3. In her history class, she got an 89 on a test with a mean of 88 and a standard deviation of 1.2. On which test did this student score better on? If we plug in her score on her stats test, subtract the mean, and divide by the standard deviation of 1.3, we get 3.08. If we plug in her score on her history test, subtract the mean, and divide by the standard deviation of 1.2, we get the answer 0.83. Because the z-score of 3.08 is higher above the mean than 0.83, despite her higher score on her history test, she actually did better on her stats test. We can use table A to find the probability of z-scores. What did you learn? What does a z-score of negative 1.93 mean? It means that the z-score is 1.93 standard deviations below the mean. What is the equation used to find z-score? It's z equals the original observation x minus the mean mu over the standard deviation sigma. These are our references. Eyla was our camera person, Mackinley was our speaker, and Joe was our paper slider. Thank you.